Hello everyone. Today I will start a new topic that is dimensional analysis. The objective of this chapter is to understand fundamental and derived quantities and their units. We shall also learn the terms dimensional formula and dimensional equation. All measurable physical quantities can be divided into two groups, that is fundamental or basic quantities and secondary or derived quantities. We refer to a small group of quantities from which all others can be formed as primary quantities. Mass, length, time, electric current, temperature, luminous intensity, amount of substance. All these are primary quantities. The secondary quantities are formed from the primary quantities. Example, speed. Speed is a secondary quantity. What are fundamental and derived units? In mechanics, mass, length, and time, these are the basic units. The units selected for measurement of these quantities are known as fundamental units. The units which are selected for the measurement of these quantities are known as the fundamental units. And what are derived units? Those units which are obtained from fundamental units are called derived units. So those units which are derived from fundamental units, are called derived units. For example, unit of speed is meter per second. It is a derived unit. Meter and second are fundamental units. Now we will discuss about dimensions, dimensional formula, and dimensional equation. Dimensions of a derived units are the powers to which fundamental units of mass, length, time, etc. must be raised to represent that unit. For example, let us consider speed. So speed is distance by time. What is the basic dimension of distance? It is L, and basic dimension of time is T. So speed is m0 L t to the power -1. This is the dimension of speed. It is expressed in terms of m, L, and t. So the speed is said to possess 0 dimension in mass, 1 dimension in length, and -1 dimension in time. Dimensional formula is an expression which shows how and which of the fundamental units are required to represent the unit of physical quantity. So dimensional formula, it is an expression which shows how and which of the fundamental units are required to represent the unit of a physical quantity. For representing the unit of a physical quantity, which fundamental units are required? that is shown by dimensional formula. For example, this m0 L to the power 1 T to the power minus 1 is the dimensional formula of speed. Dimensional equation. It is an equation obtained by equating the physical quantity with its dimensional formula. It is obtained by equating the physical quantity with its dimensional formula. So dimensional equation of speed is given under m naught L T to the power minus 1. Next, we'll study about the dimensional formula of important physical quantities. So dimensional formula of length, it is m naught L T to the power 0. It is written in third bracket. Dimensional formula of distance, it is m naught L T to the power 0. Basic dimensional formula of displacement, it is also m naught L T to the power 0. Dimensional formula of mass, it is m L0 T to the power 0. Dimensional formula of time, m0 L0 T. Dimensional formula of area, suppose area of rectangle, length into breadth. So dimension of length is L and breadth is also L. So m0 L into L, that is L square T to the power 0. This is L and this is also L. So it is L square. So dimensional formula of volume, it is length into breadth into height, that is L, breadth also L and height is also L. So m naught L cube e to the power 0. Dimensional formula of density, it is mass by volume. So m by L cube, that is m to the power 1 L to the power minus 3 T to the power 0. Dimensional formula of specific gravity, it is m naught L naught T to the power 0. That is, it is dimensionless. So specific gravity is dimensionless and it has no unit because it is a pure ratio. Next, dimensional formula of speed. We have already studied dimensional formula of velocity. Velocity equals to displacement by time. So the displacement is L and time is T. So m naught L T to the power minus 1. Dimensional formula of velocity gradient. Velocity gradient equals to change in velocity by distance equals to m naught L T to the power minus 1 by L. So the unit of distance is L. Okay. So the dimensional formula of velocity gradient is m naught L0 T to the power minus 1. Dimensional formula of momentum, it is product of mass into velocity. So dimensional formula of momentum is m L T to the power minus 1. Now dimensional formula of acceleration. Acceleration is rate of change of velocity. That is L T to the power minus 1 by T. So it will come out as m naught L T to the power minus 2. Dimensional formula of force. Force equals to mass into acceleration. That is m L T to the power minus 2. Dimensional formula of weight. It is also m L T to the power minus 2. Dimensional formula of tension is also m L T to the power minus 2. Dimensional formula of force constant. It is force per unit extension. That is m L0 T to the power minus 2. Dimensional formula of work. Work equals to force into displacement. That is m L T to the power minus 2 multiplied by L. That is m L square T to the power minus 2. This is the dimensional formula of work. Work is equivalent to energy. So the dimensional formula of energy is also m L square T to the power minus 2. Dimensional formula of power is m L square T to the power minus 2 by time, work, rate of doing work by time. So m L square T to the power minus 3. This is the dimensional formula of power. Dimensional formula of coefficient of restitution. Coefficient of restitution. It is the magnitude of relative velocity of separation by magnitude of relative velocity of approach. So coefficient of restitution is m naught L to the power 0 e to the power 0. It has no units. Next, dimensional formula of impulse. M L T to the power minus 1. This is the dimensional formula of impulse. Unit is kg meter per second. Dimensional formula of gravitational constant. We know F equals to G mm by r square from Newton law of gravitation. So G is F r square by m into m. Dimensional formula of force is m L T to the power minus 2 multiplied by radius means length square by mass means m square. So m to the power minus 1 L cube T to the power minus 2 is the dimensional formula of gravitational constant. In the similar way, dimensional formula of pressure. Pressure is force per unit area. So m L T to the power minus 2 by area is length square. So m L to the power minus 1 T to the power minus 2. Dimensional formula of stress is same as pressure. So in this way, we will study different dimensional formula in the later chapters also. Okay. Dimensional formula of surface tension. Surface tension is force per unit length. So m L T to the power minus 2 by L. So m L to the power 0 T to the power minus 2 is the dimensional formula of surface tension. So we have to remember different types of dimensional formula by remembering their formulas. Okay, we have to learn the formulas of different terms, that is latent heat, specific heat, molar gas constant, Planck's constants, etc. For calculating the dimensions, we have to know all these formulas, basic formulas. If we have to calculate the dimensional formula of charge, so charge is current multiplied by time. So the dimensional formula of current is ampere. Okay. And dimensional formula of time is T. So the dimensional formula of charge is m naught L naught T A. In the similar manner, dimensional formula of electric potential is calculated as work done by charge. So dimensional formula of work is ml squared t to the power minus 2 by charge is current multiplied by time Ta. So dimensional formula of electric potential is m l squared t to the power minus 3 a to the power minus 1. So you have to learn all these dimensional formulas. What quantity is represented by this dimensional formula m l squared t to the power minus 1? So this is Planck's constant. We know Planck's constant equals to energy of photon by frequency. So energy of photon by frequency will be calculated as ml squared t to the power minus 1, which is the dimensional formula of this Planck's constant. Now, four categories of physical quantities. So we will look into these categories. Number one is dimensional constants. Dimensional constants. Dimensional constants are those physical quantities which possess dimension and have a fixed value. Example, gravitational constant, Planck's constant. Gravitational constant and Planck's constant. Number two, dimensional variables. Dimensional variables are those physical quantities which possess dimensions and do not have a fixed value. That is velocity and impulse. These are dimensional variables. Number three, dimensional constants. These are those physical quantities which do not possess dimensions but have fixed value. Example 3, 9, these are the numerical constants. E, pi, these all are numerical constants. And number four, dimensionless variables. Dimensionless variables. Example, strain, specific gravity. Next, we will study about dimensional analysis and its applications. Number one is principle of homogeneity of dimensions. A given physical relation is dimensionally correct if the dimensions of the various terms on either side of the relation are same. In both the side of the relation, if the dimensions of the various terms are same, a physical relation is dimensionally correct. This principle is based on the fact that the two quantities of the same nature can only be added up. Two quantities of same nature, these only can be added up. The resulting quantity is also of the same nature. The resulting quantity, this is also of same nature. Now we have to convert a physical quantity from one system of units to another. Conversion of a physical quantity from one system of units to another. We first consider a physical quantity whose dimensional formula is m naught m to the power a, l to the power b, t to the power c. Let us consider a physical quantity like this. Let n1 be its numerical value of this particular physical quantity. Then the magnitude of the physical quantity in this system will be n1 multiplied by m to the power a, l to the power b, t to the power c. This will be the magnitude. Next, let us consider n2 be the numerical value of in another system of fundamental units. The magnitude of these physical quantities will be given as n2 m2 to the power a, l2 to the power b, and t2 to the power c. For the first system, let us consider this as m1 to the power a, l1 to the power b, t1 to the power c. And in the second system, m2 to the power a, l2 to the power b, t2 to the power c. So since this value of the physical quantity is same in all systems, so we can write n2 m2 to the power a, l2 to the power b, t2 to the power c equals to n1 m1 to the power a, l1 to the power b, t1 to the power c. So n2 will be calculated as n1 m1 by m2 to the power a, l1 by l2 to the power b, and t1 by t2 to the power c. This equation is to be applied only after expressing the physical quantity in absolute units. Let us solve one numerical problem. Given value of G in CGS system is 6.67 into 10 to the power minus 8 dyne centimeter square gram to the power minus 2. Calculate its value in SI system. So first, all the values are given in CGS system. We have to convert it into SI system. So the value of G in CGS system is given as 6.67 into 10 to the power minus 8. The value of M1 is in gram, 1 gram. L1 is 1 centimeter. This is in CGS system. And T1 is 1 second. Now in SI system, we have to calculate the numerical value of G. In SI system, M2 will be 1 kg, L2 will be 1 meter, and T2 will be 1 second. Now, dimensional formula of G. Dimensional formula of G. It is m to the power -1 L cube T to the power -2. So let us compare this with m to the power A, L to the power B, and T to the power C. So the value of A will be -1, B will be 3, and C will be -2. So now N2 equals to N1, M1 by M2 to the power A, L1 by L2 to the power B, and T1 by T2 to the power C. The value of N1 is 6.67 into 10 to the power -8. M1 is 1 gram. M2 is 1 kg. Value of A is -1. Value of L1 is 1 centimeter. And value of L2 is 1 meter. And B is 3. T1 is 1 second. And T2 is also 1 second to the power -2. So if we calculate this, if we convert this kg into gram, that is 1000 gram, 1 meter equals to 100 centimeter. And if we calculate this value, it will come out as 6.67 into 10 to the power -11. This is the numerical value of G in SI system. So the value of G in SI units is 6.67 into 10 to the power -11. Dyne will be converted to Newton meter square kg to the power -2. So this is the process of conversion from one system of units to another. Now let us consider another numerical problem. Find the value of 60 joule per minute on a system which has 100 gram, 100 centimeter, and 1 minute as fundamental units. So let us solve this problem. We know 60 joule per minute equals to 60 joule by 60 second. That is 1 joule per second. That is 1 watt. So what is the SI unit of power? That is what? So these physical quantities is power. So now let us put these given quantities or given numerical values in the system. In the SI system, N1 equals to 1. The value of power in SI system, numerical value is 1. M1 is 1 kg. L1 is 1 meter. T1 is 1 second. In the new system, the value of N2, we have to calculate this one. M2 is 100 gram. L2 is given as 100 centimeter. And T2 is 1 second or 1 minute. It is given as 1 minute. Okay, it is given as 1 minute. So the dimensional formula of power is M L square T to the power -3. So comparing with A, B, and C, we get A equals to 1, B equals to 2, and C equals to -3. So now N2 equals to N1, M1 by M2 to the power A, L1 by L2 to the power B and T1 by T2 to the power C. So N1 is 1, M1 is 1 kg by 100 gram, M2 to the power A is 1, L1 is given as 1 meter and L2 is 100 centimeter, to the power B is 2 and T1 is 1 second and T2 is 1 minute, to the power C is -3. So now put the values. 1 into 1 kg means 1000 gram by 100 to the power 1, gram cancel, 1 meter equals to 100 centimeter to the power 2 and 1 second by 60 second to the power -3. So if we calculate this one, the value of N2 will be 2.16 into 10 to the power 6. These units in the new system. Next topic is to check the dimensional correctness of a given physical relation. Dimensional correctness. Now you have to check whether this relation is true or not. S equals to ut plus half it square. So let us proceed with left hand side. S means distance, it has dimension L. Distance or displacement, it has dimension L. Now RHS ut plus half at square. U is velocity, so the dimension of velocity is L t to the power -1 and dimension of time is t, plus half is constant, it will be neglected. Dimension of acceleration is L t to the power -2 and this is t square. So it will be L t to the power -1, t gets cancelled, plus this -2 plus 2 gets cancelled. So this will be L, so twice L, and this 2 will be avoided because this is a constant. So in the RHS side, we also get L as the dimension. So both LHS and RHS are same. So this equation is dimensionally correct. Let us check another equation. Half mv square equals to mgh. So LHS half mv square, half is constant, so it will be avoided. Now dimension of m is capital M and v square is L t to the power -1 square. So m L square t to the power -2. This is the dimension of mv square. And in the RHS section, this is mgh. So dimension of m is m L t to the power -2 and height is length. So this is m L square t to the power -2, same as LHS. So this is dimensionally correct equation. Now let us establish the relation between different physical quantities. To establish relation between different physical quantities. We know that time period of a simple pendulum depends upon length of the pendulum, acceleration due to gravity. It may depend upon the mass of the bob used. Later on, we will find that whether it depends upon the mass or not. But let us consider it depends upon the mass of the bob and also angle of swing. These all the factors we have to take into consideration. Later on, we will derive the formula and find out on which factors actually it depends. So we can say that time period of the pendulum depends on L to the power A. We do not know that whether it depends upon L square or L cube or all that. After finding out the expression, we will know that it will depend upon the square root of length or cube root of length, all these. So first we will write that T is proportional to L to the power A. We will write all the factors G to the power B, M to the power C, and theta to the power D. Now let us put this constant K, L to the power A, G to the power B, M to the power C, and theta to the power D. Now in the LHS section, the dimension of T is capital T. Okay, and this is K, dimension of length is L to the power A, L T to the power minus 2 to the power B, M to the power C, and theta to the power D. Okay, so K is dimensionless constant of proportionality. Now let us compare the dimension on other each sides. Okay, so the dimension of L in this side is 0 because actually this is M0, L0, T to the power 1, and in the right side K, L to the power A, L T to the power minus 2 to the power B, M to the power C, and theta to the power D. So K into L to the power A plus B, T to the power minus 2B, M to the power C, and theta to the power D. So compare both sides. So A plus B, here L power is 0. So A plus B equals to 0. Minus 2B equals to T to the power 1. So 1. C is 0. D is also 0 because these are not in the left hand sides, not given in the left hand sides. So now B equals to minus half from this equation. So A will come out as plus half. So put these two values in this equation. So T equals to K, L to the power half, G to the power minus half, and all C is 0, D is 0. So it will get cancelled 1, M to the power 0, theta to the power 0. So K, L to the power half, G to the power minus half, because M to the power 0 is 1 and theta to the power 0 is also 1. So T will come out as K, L by G root over. And now from experimental condition, K is 2 pi. So T is 2 pi root over L by G. This is the actual formula of pendulum. So we calculate this formula of pendulum from the different physical quantities given. Let us now establish another relation or another formula. If the velocity of sound in a gas depends on its elasticity and density, derive the relation for the velocity of sound in a medium by the method of dimension. This is another numerical problem. So the velocity of sound depends on elasticity, that is E to the power A, density rho to the power B. So V equals to K into E to the power A, rho to the power B. So the dimension formula of velocity is L T to the power minus 1 equals to K. The dimensional formula of elasticity is M L to the power minus 1 T to the power minus 2 to the power A. Dimensional formula of density is M L to the power minus 3 to the power B equals to K m to the power a plus b. Here m to the power a and m to the power b. So m to the power a plus b. L to the power minus a minus 3b and t to the power minus 2a. Now compare with LHS. So a plus b equals to 0 because in this right hand side the power of m is a plus b and here it is 0. So a plus b is 0. Minus a minus 3b equals to 1 and minus 2a equals to minus 1. Comparing the powers of t. So a is half. Now minus half minus 3b equals to 1. So b equals to minus half. And a plus b is 0. From here also we can calculate b as minus half. Okay. So the value of a and b, a is half and b is minus half. So now put these values in this equation. V equals to k e to the power half rho to the power minus half. So V equals to k e by rho root over. This is the equation. And the value of k can be determined from experimental conditions. Okay. Now at last, limitations of dimensional analysis. So dimensional analysis, it supplies no information about dimensionless constant. No information about dimensional constant. They have to be determined either by experiment or by mathematical investigation. This method is only applicable in case of power function. This method fails to derive directly a relation which contains two or more than two quantities of like nature. Okay. It can only check whether a physical relation is dimensionally correct or not. It cannot tell whether the relation is absolutely correct or not. For example, if we write S equals to ut plus half at square, this is dimensionally correct. Now we write S equals to ut plus 1 by 4 at square. It will also be dimensional correct. It will also be dimensionally correct. But this equation is not absolutely correct. But this equation is correct. So we cannot check whether the given relation is absolutely correct or not. Okay, let us solve a numerical problem. Okay, if x equals to a plus bt plus ct square, where x is in meter and t in second, so what is the unit of c? So applying principle of homogeneity, we can write ct square equals to L. Ct square equals to L, or c equals to L t to the power minus 2. Because x has dimension of L, so we can write from homogeneity of dimensions, only same quantities can be added. So ct square equals to L or c equals to L t to the power minus 2. So unit of c will be meter per second square. The equation of state for some gases can be expressed as P plus A by V square into V minus B equals to RT, where P is pressure, V is volume, and B and A are constant. Capital R is gas constant. So we know that only quantities of like nature can be added. So dimensional formula of A by B square is same as that of pressure. A by V square is same as pressure because only like quantities can be added according to principle of homogeneity. So A equals to PV square. So the dimensional formula of pressure is ml T to the power minus 2 by L square. This is the dimensional formula of pressure, and V square is L cube square. So this formula will come out as m L to the power 5 e to the power minus 2. So A is this one and V minus B. So V equals to B. Only same quantities can be added according to the dimensional formula or principle of homogeneity of dimensions. So B equals to L cube equals to m naught L cube T to the power 0. So the dimensional formula of A and B are given here. Now find the dimensional formula of 1 by 4 pi epsilon naught E square by H into E. We know that 1 by 4 pi epsilon naught. This has unit of Newton meter square C to the power minus 2. So unit of H is joule second. So the unit of 1 by 4 pi epsilon naught E square by HC. This is HC. Okay. Equals to Newton meter square C to the power minus 2 C square by joule second meter per second. So the final unit will come out as joule meter by joule meter. So this has no units, clearly no units. Hence the dimensional formula will be m naught L naught T to the power 0. Now next question. If the fundamental quantities are velocity, capital V, mass m and time t, what will be the dimensions of eta, that is coefficient of viscosity? So here velocity is given as a fundamental quantity, not derived. M is a fundamental and T is also a fundamental quantities. So this is one fundamental quantity, this is one fundamental quantity, and this is another fundamental quantity. Velocity here is fundamental, not derived. So we know V equals to pi p r to the power 4 by 8 eta L. This is Poisson's equation. Now eta will be pi p r to the power 4 by 8 VL. So the dimensions of P is m L to the power minus 1 T to the power minus 2, and radius means length. So L to the power 4 divided by 8 is constant, and V will be L cube T to the power minus 1 into length is L. So it will come out as m L to the power minus 1 T to the power minus 1. This is eta. but L equals to V into T, because we have to express this in terms of velocity, which is a fundamental quantity here, not derived. If velocity is a derived quantity, we can write V as L to the power minus 1. But actually here, velocity is a fundamental quantity, not derived one. So we have to express this in terms of V. So L is V into T. So now eta equals to M V to the power minus 1, T to the power minus 1 into T to the power minus 1. In place of L to the power minus 1, we have put Vt. So M V to the power minus 1, T to the power minus 2. This is the dimensional formula of eta, that is coefficient of viscosity in terms of fundamental quantities velocity, mass, and time. So these are all about the different dimensional analysis. Thank you.